All right, now we're still dealing with integration using trigonometric substitution, and we're looking at case 2, where you're going to get either cot squared x or tan squared x. Okay, we've just seen how you do it when you have a sine squared x and a cos squared x. Now you have a tan squared x or a cot squared x, and they want the integral of it. Well, the things you must know are, one, you must know that you must recall that if I had the derivative, okay, if I had the derivative of tan x, then I would get the derivative with respect to x, obviously, then I would get sec squared x. And if I were to look for the derivative of cot x, then I will get negative cosec squared x. And this simply means that I can find the integral of sec squared x with respect to x, and it's going to be tan x, okay, because it's the reverse. Of course, there'll be a constant of integration c, but you can see that it's taking me back. And if I get the integral of cot x, then it's going to be, the integral of cosec squared, rather, because cosec squared is a derivative, that means it has an integral. And the integral of cosec squared x with respect to x will be negative of cot x. Okay, because positive cot gave negative cosec, positive cosec will give negative cot. Of course, you could add the c. But it's just showing that I have the integrals of sec squared and the integral of cosec squared with respect to x. These integrals I have. So if I can be able to convert this tan squared to sec squared, because I have the integral of sec squared, and be able to convert this cot squared to cosec squared. All right, but if it's in cot squared form, then it is not helpful. Well, how am I going to do that? I'll use the identities, and they have similar identities, which say 1 plus tan squared x is equal to sec squared x. That's identity number 1. Then identity number 2 is the same, but it's now for cot, and it changes him to cosec. It says 1 plus cot squared x, okay, cot squared x is equal to cosec squared x, cosec squared x, and that's the identity number 2. Oh, how nice and easy. Yeah, these are the identities we use. So therefore, if I have an integral of cot squared, I remember this identity. 1 plus cot squared is cosec squared, okay? So that would mean from here, this would mean that if I want to find tan squared, I make it the subject. I would say tan squared x is equal to sec squared x minus 1. Okay, so wherever there is, because that plus 1 goes to that side, right? And then I have cot again. I have cot squared x being equal to cosec, not cosec, it's cosec, cosec squared x, right, minus 1 again. And that's it. These are the identities I use, all right? So if I do an example real quick, if I have the integral of, say, 5 tan squared 3x with respect to x, and I've been asked to determine this, okay? They say determine the integral of this tan squared. The moment I see a tan squared, I remember the identity must be used, because I have the derivative of the other guy, the integral of the other guy. So what do I know? I am going to put tan squared here. I know that tan squared x, okay, is equal to sec squared x, okay, minus 1, because we know 1 plus tan squared is equal to, you can start with the one you know, 1 plus tan squared x is equal to sec squared. Okay, tan is related to sec. Tan is related to sec, and then the c's are related to each other. Cot to cosec. All right, so now what does it mean? Tan squared x will be equal to 1 to sec squared x minus 1. If it's tan squared 3x, then it's equal to sec, okay, sec squared 3x minus 1. All right, so now that's just what I put here. So this would therefore be equal to the integral of 5 multiplying sec squared 3x minus 1. And this is all with respect to x, okay? This is with respect to x. Now I can pull the 5 out. 5 multiplies the integral of sec squared 3x minus 1, okay, all with respect to x. And then I can separate them, which is equal to 5 multiplying the integral of sec squared 3x with respect to x minus the integral of 1 with respect to x. All right, and this is 5 multiplies the integral of sec squared, if like we just did here, is tan x, okay? Because the derivative of tan gives you sec squared. All right, so here I would then have the integral of sec squared 3x being tan 3x, then divided by 3, the derivative of that 3x. Okay, minus the integral of 1 is with respect to x is just x. All right, so now this would become the final solution, or if you'd want, you could expand it, although there's no reason to. But remember, never forget to put the constant of integration. See if it's an indefinite integral at the end, and it's not affected by the 5, okay? The C is not affected by the 5. All right, now, and the last one would be, what if I then have the integral of something with a cot? So I'd say from pi over 2 to pi, okay? From pi over 2 to pi, the integral of half of, we could say 1/3 cot squared 2x with respect to x. Okay, this is the question we'll see in the next video, and how we can solve it using the concept we've just learned.